Hello everyone, I'm Shravya. I'm going to talk about goal graph and goal operations for the next few minutes. Um, so let's start with, um, I'm sorry. Let's start with what is goal graph. Basically, goal graph is a data structure which manages and maintains all the goals of the agent within by using a tree structure. The tree structure allows us to prioritize the goals and organize the goals easily. The data structure mainly has three classes. One is goal, the other is goal node, and the third one is the goal graph. The goal basically contains ID and arguments, where ID is the predicate and arguments is the objects of the goal. And then the goal node, the goal node class has four things in it. First one is goal, and the second is the set of its parents. The third is its children, and the fourth is the plan associated with that particular goal. And then the goal graph finally associates or connects all the goal nodes within a relation. Like it might either be a parent or it might be a child to some other node and everything. Um, that's it. And then let's go to the brief overview of how a goal graph works. Whenever the MIDCA is initialized, an empty goal graph is also initialized and stored in the memory. And then uh, and then it gets all the goals from the user or the formulated goals, and then performs the goal validation. In the goal validation, we basically check two things. That is either the ID, if the ID is belonging to the domain file, that is if the predicate is present in the domain file or not, and the second is the objects, if they are valid and if they are already defined in the system file, like if all the goals are valid and if they belong to the same world which we are working on or not. And then the action which happens is, if the goals are validated and proven to be correct goals, then those are inserted into the goal graph and then stored in the memory. And then after that, they are retrieved by other phases from the memory, and then achieved and then finally removed. So let's start with the phases of the MIDCA. Here we will know what phases does the goal graph directly interact with, and how the goal graph really works. So in the cognitive layer, the perceive just observes the world and then mm, generates gives the states of the goal and then stores them. And the interpret detects anomalies, and then it is the it it is the one which uh, which initializes the goal graph initially. Like it takes all the goals from the user and then puts them into the goal graph. It validates the goals, and then it also detects for the anomalies, and then the evaluate would be watching for the act and then the perceive, and then it would remove the achieved goals from the goal graph once the goal is achieved. And then the intent would perform the selection operation from an n number of goals. It selects each goal and puts them onto the current goals, so that the goal could so that a plan could be generated for the current goal, or it could be achieved. The intent could select a single goal or some n number of goals based on any uh, any method, but currently it is first come first serve based. Like if we have n number of goals, the first goal would be selected and it would be placed in the current goal, and then the plan gets the current goal from the intent, and then it interacts with the goal graph. Then it checks if a plan already exists for that particular goal. If it doesn't, then it generates a new plan and then puts it back into the memory. If a plan already exists, then it continues with the plan. And then the act phase gets the plan of the current goal, and then it executes the actions, and then again the persive cycle repeats. And the meta layer usually monitors the cognitive layer, and the monitor phase, it just it just tells tells which phase the cognitive layer is in, and then the remaining operations are just same. And in the controller, we perform the goal transformation operation, um, and even the controller uses the goal graph. Yeah. And then so let's consider an example of the construction domain. So in this, if we want to build a tower, like say A, B, C, and then D above it, so we would have three goals here, like on of AB, on of BC, and on of CD. Initially, when a goal is given, the inter the perceive phase just observes the world. It does nothing with the goal. It has no connection with the goal graph. And the first goal is the interpret gets the goal. The first goal on of AB, it calls the goal class of the goal graph, and then inserts that on of AB goal into the goal graph as a root node, and it does the similar action with the other two goals too. It validates it and then inserts them into the goal graph. And the evaluate, it just monitors the act phase, and then it just checks if the goal is achieved or not. And at present the goal is not achieved, so it doesn't do anything. And then the intent would select the first goal, which is on of AB, and then give it to the planner. The planner generates it checks if a plan to stack A on B already exists. If it doesn't, then it generates a plan and then puts into the memory. And then the act phase does the action of like reaching to the block B and then picking it up and then stacking it on A. So only one action would be executed each time. So that's all. And then the goal operations. The MIDCA would also perform the goal operations like goal formulation, that is generating the goal all by itself. Like there is no need for an user to tell the MIDCA like it should do a particular action and everything. It is currently in the developing stage. And then the goal selection is done in the intent phase, and then the goal transformation, we'll talk about this in the next slide. And then the goal delegation, which is just representing the goal and everything. The goal achievement, which is done in plan and act phases. So why goal transformation? It is just a basic thing which we humans do in our day-to-day life. Let's say, for example, we have designed a robot with some features in it, and then we send it to a grocery store. Let's say $5 for 5 bell peppers, and we send it to the grocery store, and then suddenly the price of the bell peppers might have increased. And then if the goal transformation is not present, the robot might just go get all the 5 bell peppers and say it has become $10. It would just give $5 and then come back again. So the store owner might be chasing our robot, so we don't want that to happen. So resource availability and some cost benefits, like say some good quality bell peppers are available, or say something better is available with the same cost, or something like that. And then emergencies, say if the store is on fire, we don't want our robot to go inside it and then buy the stuff for us. So it should be able to do and act smart. So, and there might be many reasons for goal transformations. These are some of them. And then so how do we perform goal transformations in MIDCA? So we have formulated we do things on changes with the predicates and the objects in order to do the goal transformations. These are some of the things which we have implemented till now. There are many more things yet to do. The generalization, it basically jumps from more general predicate than the current one. Like if on is a more general predicate than stable on. So based on some resources available and everything, it just jumps from stable on to on if there is a possible, yeah, if there is a possibility, or it might jump from generalization to specialization based on that. Oh, I'm sorry, I did not tell about specialization. Is just the opposite to the generalization. It goes to the more specific predicate, and the abstraction is for the objects. Abstraction goes to the uh, more general objects, like say vegetables than bell peppers. The vegetable is more general object than bell peppers and something, and the concretion is quite opposite. Identity is basically the same goal. We have implemented them, and we have defined a choose function to iterate through everything and then do the transformation. I have a small demo for you guys which implements the generalization. Yeah. Okay, thank you. So, oh, thank you. So, here this is our basic world. I mean, initial world, and then all the goals which we are giving right now are the stable on goals. Um, so the first goal is stable on of A and B. We just have four motors available right now. Uh, oh, it is first unstacking everything. So now stable on of A and B is achieved and one motor is used. So we are left with three more motors, and then this is stable on of C and D, and then the next is stable on of C and A. Oh, okay. Thank you. Uh-huh. Oh, okay. Is this good?
You just give some idea of what we're looking
Okay, so this is stable on of A and C. So uh, till now we have used three motors, and we are just left with one more motor, and there is one more there are two other stable on goals which we have left with. uh, uh, those means stable ons. So I mean they have motor. So, um, so now the goal is A on C with stable on. Uh, CB. No. And then we have one more stable on goal, but we are out of motor, so it should do it should select the transformation of going to generalization, and then do on. Yeah, here. Uh,
Sorry, what's the goal here?
I think A on C. Like we are generating random goals, like I mean all stable ons of everything is stable on, but we are changing the blocks in order to see if it performs generalization after the motor is done. I mean after the motor is completed or not. Sorry, after the motor is completed, we have used up all the motor. Yeah, yeah.
Repeat the questions as you hear them also. I don't know if people online can hear the questions.
Okay, okay. Yeah, here
Oh, okay, great.
the goal transformation happened because we have used up all the four motors which we had initially, and then we had given another goal of stable on. So here.
So can you just could you just walk us through what we're like this so like it says they found an anomaly in impasse. If you would
Yeah.
just walk us.
Okay,
Never mind.
you want me to do?
Just what you're looking at now. What we're looking at right now.
Uh-huh.
So it looks like the metaphase found an anomaly.
Oh, yeah.
Oh, this mental phase.
Yes.
Yeah, it's the metaphase.
I think you're at a good spot.
Here, I mean, I think it's gone. Anomaly detection is gone already.
Can you go forward? Can you go back actually to what you were showing?
Uh-huh.
Go ahead and go up there with her.
Yeah.
Then go somewhere.
And then
So,
Here. Oh, it already went.
okay, so here.
You
yeah.
want?
Well, I was just saying. Could you just talk about like this? Like, so this is the metaphase running,
Uh-huh.
and then we get to a point where we do a goal transformation. I don't know if you could just. Yeah.
Okay. So,
Just what we're looking. What are we looking at? If you can see that.
yeah, so we are out of motor, so the plan for stable on of the given objects could not be generated. So a trace is sent to the meta level, and meta level is initiated, and then the monitor phase checks that it is in the plan phase, that uh, in the cognitive layer, that it is not able to generate a plan, and it possibly uh, I mean detects the reason that it is out of motor. So the controller of the meta layer generates a new plan of moving the stable on to on, and do the tower.
it chooses generalization.
Yeah, yeah.
Yes.
It chooses the
So the
generalization.
meta level intent is choosing the achievable. The meta goal is to have an achievable goal,
Yeah,
and then it chooses to transform the goal as the plan.
yeah, in the control.
Okay, and
Yeah.
then it's doing specialization.
Generalization, because
generalization.
yeah,
To do.
yeah.
Thank you.
Thank you.
Also, is this example available in one of the example scripts that people can actually run this example?
I don't think so.
I think this is in the master branch.
But
Yeah, it
okay,
is not in the
will be
master branch.
future, though.
Uh-huh.
Yeah, just say now this is not currently available.
Yeah, this example is not currently available in the master branch, but it would be in few days. Yeah. And so
It's new for me to see this, so it looks really cool. The different specializations and transformation.
yeah. So
Yeah.
that's all.
Is that
Uh,
you still have plenty of time if you want to talk about it.
yeah, I just want to conclude now by just saying that, yeah, all the goal transformations would make our robot or the system really flexible and self-reliant, and it would really improve the performance of the system. And then, in a broader view, I think we are moving towards the day where a human could carry another intelligent brain in a portable device. So, thank you.
Very good.